Hello, I'm Carl Ross of the University of Portsmouth, United Kingdom. Today is February the 25th, 2012, and I'm going to give you a lecture on the vibration of a composite submarine pressure hull using the commercial Finite Element program Ansys. So I start with preferences, I beg your pardon. I pick on structural, I press on OK, I pick on preprocessor, I pick on element type, add, edit, delete. I'm going to add an element here. I'm going to use a shell 93, which is suitable, 8 node 93, which is suitable for Ansys 11, but not Ansys 13. In Ansys 13, you've got to use the shell 281, very similar, but slight difference in the input. Now, real constant, input of the thickness, that is. The real constants, I'm going to input the thickness of this submarine pressure hull, and it's 5 centimeters. I'm going to work in kilograms, newtons, and meters. So I should put in there E minus 2, which is 5 times 10 to the minus 2 meters. And I shall press OK, and this is the thickness. I'll close that, and then I'll pick on material properties. I'll pick on material models. I can put orthotropic material in there, so I'll pick on structural, I'll pick on linear, pick on elastic. A little choice of isotropic, orthotropic or anisotropic. I'll bid for orthotropic because it's a simple orthotropic one layer element. I put in the EX, which is the Young's modulus in X direction, the local X direction, and I'm going to put 2E5 for that, which is, I beg your pardon, 2E11, which is the newtons. Do that again. E11 for the Young's modulus in Newton per meter squared. EY, I'm going to put in 1E11, and EZ, I'm going to put 1E11, and then for the Poisson's ratio in the XY direction, I'm going to put 0.3, and the Poisson's ratio in the YZ, I'm going to put 0.25, and the Poisson's ratio in the XZ, I'm going to put on 0.25, and I have to put in the rigidity moduli. So I'll put in here 2E10 for the modulus in the XY direction, and that's in newtons per meter squared. And then I'll put in a YZ, I'll put in 1E10, 1E10, then I'll put in the rigidity modulus in the XZ direction, which is 1E10. I've got that, that's fine. There's a facility for temperature, but I'm not going to use that. I'll press OK, and now I need to put in the density, and I'm going to put in 2000 kilograms per meter cubed. Okay, so I've done that. Now this was fine using Ansys 11. For Ansys 13, you have to use the shell 281, and you can't put the thickness in like this. You've got to use the command section, shell, layer, add layer, and then you put the thickness in. If you've got more than one composite material, you could add the additional layers, and they will be related to certain material properties. That's fine. And now I'm going to model. So I'll pick that up there. Let's get out of this. We've got material. I exit that. I'm going to model it for sections. I've got to be careful now. I'm going to change my work plane from Cartesian to global cylindrical. I'll go like that because it's easy to put it in there. I'll pick on create, and I'll pick on nodes, and I'll put an active CS, and the first node there. Now the radius of that node, remember the diameter of this submarine is 10 meters, so I'm going to use 5 there. The angular position is minus 90 degrees, and the origin is 0, and I apply that, and then I pick on the next node, which is number 2, and the radius is still the same, 5. You only change the radius if you've got a corrugated cylinder or a cone or a dome, and the angle is minus 75. The total angle of the of this element is over an angle of over a curve of 30 degrees, and the origin is 0, so I press apply, and then put in the third node, which is all in the origin, and this time the radius is 5 as well, and the angle is minus 60 degrees, and the origin is 0. I'm now going to put in the number 4 node, and the radius is 5, and the angle of that is minus 90. It's a mid-side node, and the position of it from the origin is 0.5 of a meter. I'm going to use 1 meter long elements. That's 0.5 of a meter, halfway along. I press apply, and then put number 5, and the radius is 5. This is a mid-side node, so the angle is minus 60, and the origin is 0.5. So I press OK, apply, and then I pick on node 6, which is at the top end of the element, and the radius is 5. The angle is minus 90, and the position of this is 1 meter. I'm making the element 1 meter long. That's 1 meter there. And then pick on node 7, and the angle is minus 75. The radius of course is still 5, and the Z direction along the meridian is 1 meter. And then I pick on node 8, which is there, and the angle is minus 60. The radius is still the same, and the position of this node along the Z direction is 1. I press OK, and I've got that. I don't like that that view, so I click on pan, zoom, rotate, and I'll pick on bottom there, and there I've got it. You can see the X direction. This is the X direction. It's the local direction, which is the same direction for EX. EY is in that direction, and EZ is perpendicular plane. So I'm not gonna come out of this work plane, and I must change it to global Cartesian. So I do that, and I have to create the element. So I pick elements there, and I pick auto numbered, and I've got to go like this: 1 there, 2 there. Wait a minute, through node, I haven't done that correctly. I put 1 there, 2 there, 3 there, 4 there, 5 there. And this must be done like that, or the element won't work. 6, 7 there, 8 there, and I press apply, and I've got my element. Okay, so I will pause here now, because I'm only allowed 2 gigabytes per shot, so I shall pause, and then I shall carry on very shortly. I'm going to resume my recording now. So I'm going to copy this element. So I look, and I'm going to make 3 copies. So I pick on copy, and copy. I pick on elements, auto numbered, and I pick on that, and then it's got to be in Cartesian coordinates. So put on that, make sure it's in Cartesian coordinates, like that, double Cartesian, because the next menu is going to be, this is in global Cartesian, and the total number of copies is 3. The node increment is going to be 5, because as you increase each node, increases by 5, and the Z offset is 1, and I press apply, and I've got 3 elements there. I've now got to get to my work plane and change it to global cylindrical. I'll tell you why that in a minute. I press each of these, 1, 2, 3, I press apply, and this table is in global cylindrical. The total number of copies I want is 12, because 12, 30, that's 360, and the increment of a column, first column goes from 1 to 18, the second one from 2 to 36, so we need 18 there. We get rid of that. Now this is global cylindrical, so I need minus 30 there. I've got that there, press that, and I've got my element there, and that's fine. Before I forget, I must change this work plane from cylindrical to Cartesian, otherwise when I restrain my restrain it, I might have problems. So I press OK, that's fine. I've now got to, I haven't finished with this, so I've got to look at numbering controls. I go on that, the elements are loose, I've got to merge them. I merge them there, I press that, I've then got to compress them, and I press that, and that's fine. I don't like the position of the view of this cylinder, so I shall press plot controls, pan, zoom, rotate, press right. I've got that there. I'm ready now to restrain it. So go define loads, apply, structural displacements. I'm going to put it on nodes. I'm going to pick a box here. I'm going to put this box around the right side here, which I'm going to make fixed. Be careful you don't go too far over the left, because if you do that, you might restrict some mid-side nodes. All degrees of freedom are 0. So I press that, I press apply, and then press the box again. And now I'm going to the left side here, and I restrain it here. I'm going to restrain it here, simply support it only. I'm in Cartesian coordinates, and that's fine. So I pick the box there, and I press this, apply here, and I get rid of that all degree of freedom. I'm just going to put X and Y, simply support it. I press OK, I've done it, so everything's done. All I've got to do now is put analysis type, and pick on new analysis, and it's modal, right? It's modal, which means vibration. So I picked on that OK, I've done that. I picked the analysis options, and I'm going to put 6 to expand, to extract, and 6 to expand. Press OK. I'm ready to solve it now. I press OK. I put solve current LS. Press that. I press OK, and it's done. And it's done. The problem's done. That's fine. That's good news. So I'm going to do the post-processing. So I pick on the general post-processor, and I pick read results, and I pick on the first set, and I pick plot results. I'm going to put plot results, deform shape. Alright, I'll press OK, and I'm going to look at plot controls up there. I put plot controls, and I'm going to put animate here, animate the mode shape, and I'm going to change this time delay to 0.075 to make it a bit faster. And there she goes, and there she's vibrating nicely, and that's fine, but I don't like that view too much, so I'm going to change the plot controls, pan, zoom, rotate, and I'm going to put front. I'm going to look at it from the front, and then I'm going to put plot controls again, and I animate it. I put mode shape. There you are. There she is. She's vibrating. Going to vibrate in a minute. There she vibrates. The frequency is 75.69 Hertz, and it's vibrating there with lots of lobes, and that normally happens with the large submarine because this is 10 meters diameter. Right, and that's fine. I'm going to read the results again. I'm going to put the next one. The next set is exactly the same as the first set because it's at 90 degrees. So I'm going to press next twice to get the third one, which is really the second one. I press twice. I press plot controls. I press animate. I press mode shape. There you are. And I press OK. And there you are. I've got another frequency there, which is 80.47 Hertz. That's pretty good. I'm going to get the third one. And to get the third one, I'm going to press next set twice. Press it twice. I put plot controls, and I put animate. And mode shape there. I press OK. There you are. That's 95.1 Hertz. So it's quite interesting. It wobbles there quite nicely. And I'd like to take this opportunity of thanking you, ladies and gentlemen. I'd like to also take the opportunity of thanking my colleague, Dr. Andrew Little, for his help, and also Terry, who's done an enormous amount of work in this field, and I owe him a lot. So thank you very much, ladies and gentlemen.